Hello guys, my name is Engineer Holiday. We want to discuss electromagnetic wave and as you listen, God bless you. Now, what is an electromagnetic wave? Electromagnetic wave is a wave that what arises from electric or that arises from the vibration of electric and magnetic field. So it's a wave that arises from the vibration of electric and magnetic field. These are three important points that we need to take from this definition. Now, if we are talking about that electromagnetic waves is a wave that arises from the vibration of electric and magnetic field. It just means that what? That electromagnetism is actually produced from electric and magnetic field. That's why if we split it, most of the time we call them what? EM wave. The wave is known as what? Known as EM wave. That means electron from the electric field, the magnetic field. So that means electromagnetic field. Now, an important point is that means there is a contact between magnetic and electric field. Another point is that how is this vibration or how is this relationship when they vibrate between electric and magnetic field? How do they relate? Now, the electric field is what? Perpendicular to the magnetic field. In an electromagnetic wave. Now, let me clarify that. Actually, don't forget, because the electric field is perpendicular to or is at right angle to the magnetic field, it now makes the wave to be transverse. Now, from the onset, if you look at the name electromagnetic, that means it involves electric field and also involve magnetic field. But why do we always say that? Because something has come into the definition now. We say that what? That electric field and magnetic field are at right angle in an electromagnetic wave, or they are perpendicular in an electromagnetic wave. Now, this wave, it makes it a self-propagating wave, because when we talk about electric field are they are long. They are what we call them we know we have field force, we have contact force. Now, these ones are field force. Normally, from the knowledge we have about magnetic field, they are the force that act on them are field force. Now, if the two of them are now perpendicular in a wave, meaning that these two fields now are also mutually perpendicular to the direction of the wave. Now, what I'm saying is this, let me illustrate it. Now, if I have a direction like this, let's call this one the y direction. Let's draw let's say this one is X direction, and let's call this one the Z direction. Now, what I'm saying is the direction of magnetic vibration of the magnetic field is always in the direction of the X axis, meaning that it's like this. Look at it. This is the vibration. This is direction. This is vibration. Now, the electric field is always in the direction of the Y axis. So that means it's like this. So now, if we check this movement, this one is in the Y direction, while this one is in what? The X direction. So that means if we check all this movement of the what? The magnetic field is on the X direction. It's moving like this. While for the what? Magnetic field is like this, vertical. It's vertical. So if I make a shade, let me say I shade what? Let's shade the part that belongs to the what? Electric field. If you shade it, you will now notice that there is a what? A right angle between magnetic and electric field. This one is what? This right angle. That means this one is for what? Magnetic field, which act in the what? In the X direction. This one is for what? Electric field, which act in the Y direction, in the Y axis. This one in the X axis. Then we have this one is what? This one here is the direction of the wave. So this indicates what? Direction of the wave. Direction of the wave. So that means that the three of them, the magnetic field, the electric field, and the direction of the wave, are mutually perpendicular. Mutually perpendicular means they are at right angle to what? To each other. Now, that means that all what? Electromagnetic wave, all electromagnetic waves are what? Are transverse wave. It means that all electromagnetic waves are transverse wave, meaning that the vibration of the wave is determined by the what? By the electric and magnetic field. That's why we call them, the two now combine to give the name electromagnetic. Electromagnetic what? Then because they vibrate, they move in a what? In a simple harmonic motion. We can now call them what? Electro. Because from the electro for producing electric field, magnetic producing magnetic field, combined together because they exhibit a what? A kind of wave. We call them what? Electromagnetic wave. That means a wave that is generated, a wave that is produced or that arises as a result of vibration of magnetic and electric field moving in what? In at right angle to the what? To the direction of the wave. To the direction of the wave. Sorry, this should be wave. So direction of the wave. So in that case, and a transverse wave is a wave that is defined when what? The oscillation, the oscillation of the wave is perpendicular to the direction of the wave. That's what we call a transverse wave. A transverse wave are waves that what? Its oscillations of the wave is at right angle or perpendicular to the direction of the wave. The oscillation of the wave are the vibration of the wave. Now, those vibrations are being controlled in this electromagnetic wave by electric and magnetic field. While the direction of the wave is what determines the propagation of the wave. Now, don't forget that means that determine the direction of the wave. Now, it means that the velocity that will be produced here will be produced as a result of what? The electric field and magnetic field. Now, which is what? 1 over square root of what? Mu naught epsilon naught. According to Maxwell's equation, Maxwell's equation, it says what? That velocity of electromagnetic wave is gotten by what? By 1 divided by what? Square root of mu naught and epsilon naught. Now, what is epsilon naught? Epsilon naught is called the permittivity. Why what? It has a value of 8.85 times 10 raised to power minus 12. Then we have what they call what? Mu naught. Mu naught is called the permeability. Now, this permittivity is constant or proportionality in an electric field or magnetic or electric force. While this one is what? Constant or proportionality in magnetic field or magnetic force. So this one is 4 pi times 10 raised to the power minus 7. So now these are what? And if you put this value now, if you solve it within those values, you have approximately 3 times 10 raised to the power 8 meter per second, which is the speed of light. So this is the speed of all electromagnetic wave. So every wave that exhibited electromagnetic wave all have this speed in a vacuum. Now, it means that what now? That electromagnetic wave does not require medium for their propagation. They are self-propagating. That's number 1 point now. Electromagnetic wave are what? Are self what? Propagating wave. And require what? No what? No medium for its what? Propagation. So for them to travel, they don't require medium. That means they can travel on their own through what? Air, through solid, and even through what? Vacuum. They don't require medium. If you must have heard of mechanical wave. Mechanical waves are waves that require medium for their propagation, and they can be either longitudinal or transverse wave. But in this case of electromagnetic wave, they are always transverse, in the sense that the electric field and the magnetic field are what produce the vibrations which now move in what at right angle to the direction of wave, which makes them always what? A transverse wave. Don't forget, the direction of the wave is always in the z-axis, while the electric field on the y, then magnetic field on the s, all together are mutually what? Perpendicular. So they are self what? Producing wave. And another thing again you must know is that that's why the sun can get to us, can get to the earth. The sun can reach the earth. Then also, they can pass through what? A medium. It's just that they will be absorbed by the medium. For example, light what can travel through what is a glass material, because glass material are transparent material. That means they can be absorbed in that case. They can also be reflected to create a shadow. For example, if you of what pass them through an opaque object, you notice that opaque object will cast a shadow behind the wall, because the light will not be able to get them through reflection. The light will be reflected and create a shadow behind the opaque object. Just like if I point light to myself, now I am opaque object. All humans are opaque. If I point light to myself, it will create a shadow of myself behind me. It means that I am an opaque object. It has been created as a result of what? Reflection. Therefore, the electromagnetic wave has some characteristics of wave. When I say characteristics of wave, it means that they have the ability, they can what? They can reflect. That means they can undergo what? Undergo the characteristics of wave. Or let me say they have the following characteristics. Number one, they undergo what? Reflection. They can what? Refraction, diffraction, interference, the last one is polarization. Although, no, polarization is not for all. I say they have the following, they have the following what? Characteristics. Number one is reflection. Number two is refraction. Number three, diffraction. Number four, interference. And number five is what? Now, this is exclusive to, these characteristics of wave is exclusive. That means it's only for transverse wave. That's what I mean by that. Because if you check, all electromagnetic wave does not undergo polarization. So we are going to explain that under wave. So all electromagnetic wave does not what? Longitudinal wave rather does not undergo what? Polarization. So in that case now, we are talking about what? Transverse wave is an exclusive property to only transverse wave. Now, let us discuss, we have discussed that. Now, another thing again you must know about light is that we know that light travels on a straight line. Light travels in a straight line. Light travels in a straight line. That means electromagnetic waves, all electromagnetic wave travels what? Travels in a what? Straight line. This is a property that is explained by what? Rectilinear propagation of light. So electromagnetic wave travels what? Electromagnetic waves travels what? In a straight line. So please take note of that. That is another thing you must know about them. They travel in a straight line. Now, if you have agreed all those things that we've talked about, then another thing again you must note that is very important is that they also what? They have that ability to what? To pass through a vacuum. When they pass through vacuum, we say that what? They have this particular what? This particular speed of what? Of light. Now, we have also said that they can be produced as a result of what? Being in contact with a magnetic field and electric field being in contact with each other. And that contact must be that the electric field must be at right angle to the magnetic field. Or the electric field and the magnetic field are at right angle. And even at right angle with the what? The direction of the wave, which makes them all transverse wave. Now, we have also declared that also what? That electromagnetic waves are waves that travels in what? In a straight line. And they also have or exhibit the characteristics of waves. Now, we also discussed that they can pass through a medium, but they don't require a medium. When they pass through a medium, they don't forget that when we talk about electromagnetic wave, we have different types. We have the This is a shortcut to remember them. We have the gamma. Is the gamma. This is what? X-ray. We're going to explain now in this class. Their sources and their uses. Ultraviolet. We have the visible what? Light. Then we have the infrared. And we have the what? The radio wave. So this one is just a shortcut to remember all these things. Now, in this particular case, now we know that these are the classes, or these are electromagnetic spectrum. Why do we call it spectrum? When you can split what? When electromagnetic wave is being splitted into its frequencies or wavelength, we call them spectrum. That means when we want to split them into the range of frequencies or wavelengths, we call them spectrum. So in that case now, that means that if you can have the ability to split all these, which they all have their various wavelengths and frequencies, so we can, if you are the range of frequencies of all electromagnetic waves, or the range of wavelengths of all electromagnetic waves, is what we call what? Electromagnetic spectrum. Now when we talk about this, don't forget that I told you they all have the same speed in a vacuum. But when they pass through air, or when they pass through medium, they have different speed. They only have the same speed of 3 times 10⁸ in what? In air. But we have also explained the phenomenon that while they pass through a medium, for example, a solid medium like glass, you understand now, glass is a solid medium and they are transparent, so they allow light to pass through by absorbing the light. They can also reflect light. They can be reflected by a solid body. If the solid body is an opaque body, they can travel through air. That is why the sun can get to us, to the earth. The sun reaches the earth through what? Transferring what? Or traveling what? Electromagnetic wave traveling through air. So we have explained all that. I want to give you an assignment here for you to do for me. And the assignment is this. They said what? Electromagnetic wave. Electromagnetic what? Waves or wave are least affected by which of the following? Now, which of the following have least affected what? The what? The electromagnetic wave. A, the air temperature. B, the atmospheric temperature. B, or atmospheric pressure. Atmospheric pressure. B, atmospheric pressure. C is what? Vapor pressure. Vapor pressure. And D, wind pressure. So these are the what? This is one of the questions I want to ask you. So which of the following is least affected by what? By electromagnetic wave. Now, don't forget to answer this question and send your answer in the word to us in the comment section, because so that we can assess your word, your question. Now, the last one I want to talk about before I leave is that this one we'll talk about them in the next class. We'll talk about them in the next class, but for now, I'm doing introduction. Don't forget, these are examples of what? Examples of electromagnetic wave. These are examples of electromagnetic wave. So now there are all of these answers will be discussed in the next class, because if I want to go to factors that affect electromagnetic wave, I think that will help you to answer this question, which means that you have to follow us in our next class, watch the next video so that you can comprehend better what will be the answer to this question.